And the concept of induced EMF or the induced current that we discussed last time, that can also be defined with the help of Faraday's law of electromagnetic induction. So Faraday's law tells that if you change the magnetic field lines, because in this topic we discussed that if the magnetic field lines is changing with a fast rate, so it will give you a greater value of induced EMF or induced voltage or current. So basically, magnetic field lines are cutting the coil. So if you increase the rate of these cutting lines through the coil, so that will give you a maximum value of the result in output. We also discussed the working of AC generator, that how AC generator works, because in AC generator we have one component which is different from DC motor, and that is called slip rings. So basically, slip rings are two individual rings connected with one end of the coil, and the other ring is connected with the other end of the coil, and that generates alternating current in the coil. And we also practice some questions related to the concept of AC generator and DC motor last time. So after that, we have one topic in this chapter also that is related to transformer, because in past papers we practice questions related to electromagnetic induction and electromagnetism. And after that, we have one more topic left in this chapter related to transformer. Transformer. So basically, the word transformer tells that we are transforming one form into another form. So basically, in this topic, we actually transform voltage from uh, low voltage to high voltage, or high voltage to low voltage. This is the basic concept of the transformer. And if we talk about the working principle, so it works on the principle of Faraday's law of electromagnetic induction. Faraday's law means the same rate of change of magnetic flux. So if we have greater change in the magnetic field lines, so that will gives you the greater value of induced EMF. So it works on the principle Faraday's law of electromagnetic induction. And now, if we discuss the setup of the transformer, the structure of the transformer. So first, if we consider the setup of transformer, so in transformer we have two sides and we have two coils. So for example, this is the left side of transformer. This is the right side. So this is actually the frame of transformer, or we call armature, on which we are going to place the wires. So on left hand side, we have one coil connected. And on the right hand side, we have another coil connected. And let's suppose it is connected with any output source. For example, it is connected with a lamp. So on left hand side, we have AC source of current we are using. We are not using DC source in it. We are using AC source. And one more thing we notice that on the left hand side, we have less number of turns of coil. On right hand side, we have more number of turns on the coil. So this is the difference in the transformer, because with the help of the number of turns, uh, in the output, we will get the different voltage. Let's suppose now we have more turns in number of coils on right hand side, like in output. So it gives you a greater value of voltage in output. If we have more number of turns on left hand side, like on the side of the source, so if we have more number of turns in the source, so it means that in output you will get less number of voltage or less value of the voltage. So it depends upon the number of turns. So on left hand side we have voltage of primary coil, and on right hand side we have voltage of secondary coil. So the left side represents primary coil, right side represents secondary coil. So on left hand side we have second primary, and on right hand side we have secondary. And if we talk about the working of the transformer, working of transformer is very simple. On left hand side, we have alternating current source connected. And because of alternating source of the current, the direction of the current changing alternatively, and it also produces alternating magnetic field. So because of that alternating magnetic field, the magnetic field lines or the direction of the magnetic field lines alternatively changes. And just like we discussed, because of the change in the magnetic field lines or because of the change in the magnetic flux linkage, an EMF induced in the coil. So that EMF or induced current, uh, we got that induced EMF or current in the form of output from the secondary coil. So that is the concept of the working for the transformer. So the first thing is an alternating current in primary coil creates an alternating magnetic field in soft iron core. So basically the frame we are using for the transformer, that is made up of soft iron core. And secondly, uh, these field lines that are generating from the primary coil, these field starts to interact with the secondary coil. So this field interacts with secondary coil. When it interacts with the secondary coil, so finally, because of change in magnetic flux linkage, so the third point is due to rate of change of magnetic flux linkage, an EMF is induced in the secondary coil. So this is the working of the transformer, very simple. And basically, one more question, like why we are using transformer if it only change the voltage from low to high or high to low. So we can use some other sources to increase or decrease the voltage. Why we are only using the transformer for this purpose? So basically, when we are traveling from one city to another city through train, so you observe that we have poles and we have very long wires connected, and they are passing from one point and they are connecting one terminal to another terminal through a long distance, and there are a very long length of a wires connected passing through the pole. So basically, when the electricity generates in AC generator, let's suppose if electricity generates because of the dam, so because of that process of the dam, definitely we generate electricity from the hydroelectric or any source of energy. So we have to store that energy, we have to store that electrical energy, and then we transfer that electrical energy from the main power plant to the normal city, town, home, office, etc. So to transfer that electrical energy from one point to another point, definitely we use some sort of devices. So that device is the transformer. So transformer helps you to transfer that high voltage from the AC generator or from the power plant to normal homes and offices or in the town. So that's why we use transformer. And exactly how we why we are using the transformer. So let's suppose they used to ask this question in the past papers also, like in long transmission of the voltage when we have to transfer voltage from the main source of electricity to the town, city, etc. So why we use high voltage and how transformer works over there. So question is, why were transformers developed? So basically, answer is very simple: to reduce power loss Because definitely when we are transferring electricity from the main source to the town or city, so we try to transfer the maximum amount of electricity from one point to another. So that's why we try to reduce the power loss. So to reduce power loss during transmission in long cables, so basically we have to increase the voltage at that point. And when we transfer to the town and city, so we know that in our home we are not using very high amount of voltage. The normal voltage we use in our home is 220 to 30, somewhere we have to 40 to 50 also, but this is the minimum, this is the average range of the voltage that we use in our normal homes and offices. But definitely the amount of voltage generates in the power plant, so that is in like thousand and in 10,000 of the values. So we are not using that much high amount of voltage. So that's why we have to transform that high voltage into low voltage. So that is the main purpose of the transformer. So, and that concept of the transformer we are using to convert high voltage into low voltage or low voltage into high voltage. So basically this can be achieved by increasing voltage and decreasing current. Because when current decreases, so when there is a low value of current, so because of the low value of current, there will be less resistance. So because of less resistance, we have less amount of power loss. So this is the scenario that actually happens in the transformer, right? Any question in this? Okay. Now, the concept of increasing or decreasing voltage, we have two types of transformer. For example, if you want to increase the voltage in output, so that can be increased with the help of step up transformer. So that is called step up transformer. And secondly, if we want to decrease the voltage in output, so definitely we have to use step down transformer. So the first category is called step up, and second step down. So basically in step up transformer, definitely we have to increase the voltage in the output. So in step up transformer, the value of voltage increases and the value of current decreases, because resistance and voltage are directly proportional. So if voltage is high, so definitely resistance is also high and the value of current is low. And for a step down transformer, we have low voltage, but the value of current is high. Now, just like the diagram we observe over here, so in this diagram, we can see that the primary coil have less number of turns, and in secondary coil, we have more number of turns. So this diagram shows you the concept of step up transformer, because in output, we have more number of turns. But let's suppose if you reverse this diagram, or if you flip this diagram, and if we have more number of turns in primary coil and less number of turns in secondary coil, so that gives you the concept of step down transformer. So this is the difference between the step up and step down. Very simple. Just increase the number of turns in primary coil, so that gives you the concept of step down. And if you increase the number of turns in secondary coil, so that is the idea of step up transformer. And in transformer, we also have a formula to calculate any unknown quantity related to the transformer. So let's suppose if we discuss the formula also, because in past paper, most of the time, in past paper, you observe that question related to the formula to calculate the number of turns, to calculate the voltage, to calculate electric current. So the second difference between a step up and step down is the number of turns in secondary coil is greater than the number of turns in primary coil. It means the voltage of secondary coil is greater than voltage of primary coil. In the same way, number of turns in primary coil is greater than number of turns in secondary. Voltage in primary is also greater than voltage in secondary. So number of turns and voltage both are directly proportional. If you increase the number of turns, voltage also increases. And if we talk about the power, so power remains the same. Power remains same. Power remains same. And in the same way, if we talk about the electric current, so as we discuss in a step-up transformer, current down. So it means the current in secondary coil is less than current in primary coil. On the other hand, current in secondary coil is greater than current in primary coil. And if we talk about the usage of this type of transformer, so we use a step-up transformer. Uh, we connect a step-up transformer after AC generator. So it is after AC generator before transmission. So before transferring voltage from the main power plant to the city, we connect connect a step-up transformer. So it will generate, or it will provides you a greater value of voltage in the output. So the value of current decreases and there will be less power loss. And if we talk about a step down transformer, So definitely we use a step down transformer in our normal town and in our normal outside the home office, etc., because we have to decrease that voltage which we are receiving from the main power plant. So it is used after long distance transmission to decrease voltage back to 220 or 240 volts depending upon the requirement. So this is the purpose. And according to the concept we discussed in the difference, the number of turns is directly proportional to the voltage. So it means that if we increase the number of turn in primary or secondary coil, so you will get the greater value of voltage over there. So for example, if we apply the formula according to this concept, okay, so according to the concept of the formula, so let's suppose starting from the basic idea, if we have number of turns in secondary coil, so that is directly proportional to the voltage in secondary coil. In the same way, if we find out the ratio with the number of turns in primary coil, so same voltage in the primary coil. So this is one equation. So this equation helps you to find out any unknown quantity given in the formula. So this is one idea. And you can shuffle and rearrange the values according to your choice, according to the unknown value given in the question. In the same way, if we talk about the concept of power, as we mentioned in both types of transformer, that power is same. Power is same means that the power in a primary coil is equals to power in secondary coil. It means the formula of power is VI same VI. So this is another equation that helps you to calculate the reference of voltage with electric current. So this is another formula, right? So you can calculate unknown voltage, you can calculate unknown value of electric current, or if you want to find out the number of turns for any type of the transformer given in the question, so you can calculate with the help of these two equations. So these two equations helps you to calculate the numbers related to transformer. And for example, if we consider questions related to the transformer, so let's see. There are multiple questions available in the past papers, and mostly we know that transformer topic is very basic. There is like a very simple phenomena of the working of transformer, and equations to calculate the quantities are also very simple. So the first question, okay. This is first question related to the transformer. Question number 7. The voltage across the primary coil of 100% efficient transformer is 220 volt. So transformer is 100% efficient, and this is the voltage of the primary coil. This is VP, and the voltage across the secondary coil is 12 volt. So this is the voltage of secondary coil, and the current in the secondary coil is 2.5 amperes. And we have to calculate current in the primary coil. Current in primary coil. So now you can see we have only the quantities of voltage given, only the quantities of current given, and it is 100% efficient. Why this point is given? 100% efficient means if it is 100% efficient, so definitely power remains the same. So we can use this equation. This equation is especially for a 100% efficient transformer because input is equals to output. So there will be no loss. So we use the same phenomena over here. Input is equals to output. We have to find out the value of IP. Value of secondary coil is 12 and 2.5. Voltage of primary 220. So 12 multiplied by 2.5 divided by 220, 0.136, 0.14 ampere. This is the value of electric current. And the second part is calculate the ratio of the number of turns on the primary coil to the number of turns on the secondary coil of the transformer. So they are talking about number of turns on primary coil NP and number of turns in secondary coil NS. We have to find out the ratio. So ratio means, let's suppose if we write NP over NS, it is equals to VP over VS. So the voltage of primary coil. Voltage of primary coil is 220, secondary is 12. Eighteen 18.3, round of 18. So it means that you can write down 18, or in another words, you can also write like this. For example, 2 6 are 12 and 2 3s are 6, 55. 55. Yes. So 55 by 3, or you can also write 1 by 18. So that will give you the same scenario. You can also write 18 round off by 1. So This is the ratio for the number of turns in primary coil to the secondary coil. And you can see this is a 5 mark question, a very basic question from the transformer. Just need to apply a direct formula and you will get these 5 marks. Okay, this is another question related to the transformer. The electricity supplied to a town is transmitted using a high voltage cable. A transformer in the town has a soft iron core. Explain the principle of operation of a simple iron core transformer. So basically, this is a copy paste question uh, from the working of the transformer. So we already discussed the working of the transformer. In transformer, it is very important to show that we starts from AC source, not DC source. So we are using AC source in the primary coil. This is AC source. So basically, if we use the concept of the AC source and then we connect with the primary coil, then we have a primary coil rounded up on the soft iron core, and then on the other side we have secondary coil. And due to rate of change of magnetic flux linkage, we got voltage in the output. So we need to mention the same thing over here. So this is just a copy paste answer from the working of transformer. And B part, the transformer steps the supply voltage down. So it means it is a step down transformer from 220,000 volt to 33,000 volt. So this is the voltage of primary. This is the voltage of secondary because it stepped down. And there are 450 turns on the secondary coil. Number of turns on the primary coil. So basically we have number of turns on secondary coil is given. Primary coil is not given. So again, voltage and number of turns are given. So NP equals to VP NS VS. So the value of VP multiplied with NS divided by VS. So the value of VP is 220,000. Value of NS is 450. Value of VS is 33,000. So answer is 3,000. Second part is the electrical power transferred to the transformer by high voltage cable is 77 megawatt. So calculate the current in the primary coil. So they are asking about the current in primary coil and power is given. So it is transferred to the transformer. So this is 77 megawatt. Now we have to calculate the value of electric current. So we know that the formula of power is current into voltage. So with the help of this formula, we can easily calculate the value of the electric current. So basically it is mentioned the electrical power transferred to the transformer by high voltage cable is 77 megawatt. So mega means power positive 6. So power is 77 10 to the power 6 divided by voltage. Voltage of the primary is 220,000. 77 mega divided by 350. So this is the value for of the current for these wires. So you can see very high amount of electric current passes through these wires. Normally in our daily life, we are not using such high value of electric current in our circuits. So this question is of 9 marks. So it is also easy question for 9 marks. Okay. Question number 11. It shows a solenoid connected to a battery. On figure 11.1, draw the pattern of the magnetic field inside and around the solenoid. Indicate the direction of the magnetic field with an arrow. So we have to draw the magnetic field line. It is for 3 marks, inside and outside also. According to the direction of electric current, you can see the direction of electric current is also given. It is going towards right from the top, going towards left at the bottom. So to identify the direction of magnetic field lines, we have to use right hand grip rule because current is given, only current is given, and we have to find out the direction of uh, the magnetic field lines. So that's why we have to use right hand grip rule because there is no external magnetic field, otherwise, we have to use left hand rule. So we have to use right hand grip rule. So according to right hand grip rule, current is moving towards right from the back of the coil and towards left from the front of the coil. So if you curl your fingers, so you have to consider like thumbs down because when you use the thumb down position for right hand grip rule, so you will observe that the direction of current is exactly in the direction of the curl of the finger, right? So in this diagram, we have to use thumbs down concept. So when you consider thumbs down direction, so it means thumb is in downward direction. So that represents North Pole in bottom side, South Pole on the top side. So the magnetic field lines will be from north to south. Like this. So it is from north to south. So we have to show direction from north to south. So this is the pattern of the magnetic field around this solenoid. And B part is electrical power is transmitted at a voltage of 400 kilovolt. A transformer reduces the voltage to 33 kilovolt for use by heavy industry in large factories. The number of turns on the primary coil of the transformer is 11,000. So basically, this is primary coil voltage and it reduces to 33. Then the number of turns in primary coil is 11,000. We have to calculate the number of turns on secondary coil. It means NS. So it will be NP over NS equals to VP over VS. Or if we consider NS as a subject, over VP. Number of turns in primary coil is 11,000. Voltage in secondary coil is 33,000 divided by 400 kilovolt. So 11,000 multiplied by 33,000 divided by 400 exponent 3, 907. So there will be 907 turns in the coil in this transformer to maintain the value given in the question, right? So these are some questions related to the transformers and the concept of electromagnetic induction. Now from this specific section of electricity and electromagnetism, now we can solve any question from this topical file. We already solved many questions from this topical file. Some questions from the new papers are left. So first try to solve those new questions from this topical file, then move on to the old questions. So in this way, like in next class, we will also practice the questions from this topical file and we will solve combined questions from electricity and from electromagnetism plus electromagnetic induction. And after that, you can also practice questions by yourself from this specific section, right?